Okay, now new module. So what we did before, so we looked at fundamentals of logic and reasoning, so standard logic, and we had a quick glance at fuzzy logic as well. And so that's what you will be tested on, I mean, in this quiz. So now I want to kind of roll back to our initial motivation about programs that reason, and talk about different modes of reasoning. So there are different assumptions we make to enable reasoning, and depending on these assumptions, your reasoning can be of different types. So the taxonomy here is not very complex. We have only two opportunities. So in the one case, we assume that everything that we know about the world is already in the knowledge base. And the second case is that our knowledge base is not complete, and we are discovering new facts as we go, basically. And both of the cases exist. So the first case is also known as a closed world assumption. So, and the kind of motto or very rough definition of this closed world assumption is everything is prohibited if not explicitly allowed. So this is the case for classical expert systems databases, etc. So what we have in these databases, that is what we have to deal with. And the type of logic that we can apply here is that we can only use the facts that exist in the knowledge base. So so the example is kind of illustrated here. So if we have an entry that with a certain statement that John loves Mary, this is the only thing we can infer. So we cannot infer the opposite, so the bidirectionality. So, and sometimes, so if these new facts appear, not sometimes, but if at some point in time this new information becomes available, then we have to be aware that it might lead to to conflicting situation with other facts. And as you have read in this chapter, suggested chapters, in this case, you need to revise your knowledge base. So you need to revise your beliefs. So do belief revision. But I mean, given consistent knowledge base, you still can do reasoning, but this type of reasoning that you can do on this available facts is called non-monotonic. So it means that if something is not known, then it is assumed to be false. And then, so again, so maybe I shouldn't spend more time on this illustration, or I should have used this one instead of yes. Yes. Sure. Yeah, so this is really an illustration. So if we consider our world in a continuous time, so we can so at each given time, so the set of situation is described through a set of facts, but then there are periods or time points in time when we add new facts and we need to revise this rule. So at the end, so we maintain. So at certain point in time, we have a database that is consistent with all that we knew before, in a way that the conflicting entries are resolved. And as you know, that this is a kind of complex process. So what means with this illustration is that certain new properties, like for example, obtaining new skills of this person leads to well, some skills could be complementary, so they are not in conflict, but some skills like being a student would invalidate the skills of being in a kindergarten, for example, and etc. And so on, so forth. The second type is about the assumption of open world. So basically, under this assumption, everything is allowed if not explicitly prohibited. And so that's what this is the principle behind semantic web that we will be talking about in the second part. And the variant of reasoning that you can do is that unless it's explicitly said that the statement is false, you cannot assume that it is false. And so it may be simply not known at the moment. And so this is a special type of reasoning. So it's kind of less maybe precise, if you wish, because obviously, if you assume this open world possibility, then it is hard to maintain consistency. So you cannot do belief revision, for example, simply because some facts are not known. And the type of logic that you can apply, so type of reasoning, is called monotonic. It means that it's a discovery-driven inference. So you start with certain description, and then you complement and on demand when needed. You complement your knowledge with new facts. Well, in this example about skills. But what about then? What about the fact of changing of specific of certain phenomena or certain object in time? So how to deal with it? So if we cannot do revision, belief revision in our knowledge base, still it doesn't invalidate the fact that world objects are transformed in time with respect to the properties, relationships, etc. Well, in this case, you need, and this is also, I think, part of the. I remember part of the chapters in the book. So you should annotate, basically, the part of knowledge. So you should annotate the validity period for the knowledge about certain subjects. So in a way, so you create different copies of the knowledge base, or you assume they exist, valid for a certain moment, for certain interval of time. So non-monotonic reasoning, that's what we did before. Well, actually, it's not exactly. So we didn't do non-monotonic reasoning, but an example of non-monotonic reasoning. So you have an expert system, And this expert system contains knowledge about certain domains. So in this case, again, certain possible relationships or observation of relationship between the three people. And so this knowledge is explicit. So this is the only thing you have. And the task of non-monotonic reasoning, so it is inserted in the knowledge base. Again, so you can apply different logics here, but even a simple predicate logic is enough to describe the situation. So you kind of first formalize it in forms of rules, and this is your this becomes your database knowledge base. Then what you can do with this type of the system is that you can have different starting points. So depending on what you want, so you may have different starting assumptions. So what if, for example, so what happens in this world described by these rules if we have this kind of initial starting point? So that John loves Mary and Mary is the friend of Pete. So this is your query. And under the non-monotonic reasoning, so then you basically apply these rules pretty much in the same way that we did with our little example. Well, here is an application. I mean, you apply them sequentially, but so now I will just scroll it until the end. So eventually, so when doing the resolution in the propositional logic sense, you come to the final state. So starting from the fact that John loves Mary, and what was it? Yes, and Mary is a friend of Pete. So you come that in this world model described by this knowledge base, this is the stable state. So this would be an example of another query, so with another starting conditions. And again, so the purpose of reasoning would be starting from this initial assumption, applying all these 9 rules to come up with the final state. So what does this imply? And this is pretty much, if you think, would be the mode of working with an expert system that, for example, makes assists with determining a diagnosis of a certain disease. So you start with certain symptoms, describe certain relationship, and then without any having any specific disease in mind, and then it converges. So based on the starting point, it gives you suggestions about the relationship. So underneath, so it goes. There is this algorithmic process that do this resolution. So in this case, propositional logic, but then you can think about more complex logics in the same way. Our focus is more of reasoning in a discovery-driven reasoning. And the mode of this reasoning we tried in this example. So now I want to make this kind of distinction. So if you reflect on, if you reflect on that example, with navigate in this world, and that's what you have in this WOMPOS in the lab 1. You do discovery-based reasoning, about the so you discover the environment. So you start with some basic rules, and then you discover new facts about the system. But as soon as you have discovered certain facts, so you kind of transition into this closed world type, so where all facts are set, and you perform for navigation is in this discovered world, so you are limited by the facts that you have discovered. So now we are kind of expanding this open world assumption to a larger scale. So we we talk about all the information that is kept in the internet, and how to transform this information into knowledge. So this was and how to implement reasoning on this knowledge. And obviously it fits this open world assumption, and so most likely we will need this monotonic reasoning, like discovery driven. Why would we need to do that? Again, so maybe I will repeat myself a little bit, but now we have a very diverse set of resources, digitalized resources, with complex interrelationships between them. So basically, they use the services of each other, etc. And new services, they are constructed through interoperability and collaboration between different components. So, and in these settings, we are talking about a need for some standardized way to enable this interoperability, so that this standardized way can be used by different actors. I mean, starting from users to engineers to administrators, etc., in some unified way to build this system, maintain the system, and use this system. So now, again, based on this standpoint, we need to somehow make sense out of all the information resources that exist out there, and somehow unify their understanding. So we are talking about adding something to resources that we are using, which enables reasoning on them, on their relationship, or their interoperability, etc. And to do that, I mean, the main transition is that each resource that we are dealing with, it should be accomplished with meta information describing their capabilities. So, and if you think about it, so this is essential starting point to enable, well, I say reasoning, but to enable our decisions, the decision-making process. So this is the fundamental property of resources. So we know what these resources are capable of in order to understand whether this capability is something that we need and we can use for our purposes. So, and that's what we will be talking about. So each resource should be able to be characterized by different capabilities in certain way. And again, so talking about, well, given another analogy, So we want to transition from specific products like a car to something that describe its service. So this is the type of transition we are looking at. So technically, we are talking about a system like where each resource, and we will be talking about what kind of resources we mean here, are accompanied with a software unit, which is a virtual representative of this resource. So there is this bond or link, semantic link, so between this virtual representative and the actual resource that enables this software pieces to interact on behalf of the resource to achieve certain goal. So here already on this slide, so again, so we meet this word semantic. So semantic is a little bit complex term, I think, because previously we used word semantic as in a rather restricted sense. So in the case of propositional logic, so for us semantic was a definition of truth of each sentence. So that's a very technical definition. Here we extend semantics really to its general sense. So describing like a global meaning of object and the relationship. So let's consider this case and let's think about challenges for introducing semantics or automating semantical descriptions and reasoning based on semantics. So a simple example of communication between people. So we use different modes of communication. So say verbally we say we love you, while we load this specific message with one meaning. The exactly same message for a different person, and that's very obvious. So the messages can be the same, but the meaning can be completely different, right? And I guess you understand here. So it's super important that we agree on this on the common meaning of what we say, because otherwise, I mean, well, in the best case, we come to misunderstandings, but globally, I mean, we have incorrect functionality of the system. Problem is that we can express same meaning in various ways, which are still understandable by syntactically, grammatically, it can be understood. So we can agree on the rules on how to communicate the message. Still having the same meaning. And this doesn't, so this only make the problem more complicated. So we can agree on syntactic grammatical rules. So the message can be conveyed in very strict manner without losing information of the message. But the knowledge, but we still have the problem of conveying the knowledge. I mean, the meaning of this message. Now, maybe I need to stop talking for a moment here, and let you participate in this discussion. So we are about to make these links. So these links have to be automated. So the automation between the say different forms of conveying the same meaning and the link from the communication form to the actual content. So let's spend maybe 5 minutes. So you discuss based on existing technologies. So how would you approach solving this? So what are the challenges? And let us discuss, I mean, the feasibility of this thing. And I can tell you, so I mean, I don't have kind of unique answer to this. Well, I have an answer in the way that we will consider certain technology for doing that. But I think, I mean, there are more possibilities to that. So let's talk about, let's think about it and discuss. So please, yeah, you can talk to each other. You can use chat or Discord to think. So suggest me technical solutions on how to automate this.
Hi, can you hear me?
Yes, I can hear you. Yes.
So could we do some intermediate representation of meaning of words, maybe somehow?
That's one of the possibilities. Yes, that and that is kind of towards the way we. I mean, you think in the direction of what we will be talking about in the next few classes. Yes, that's one of the solutions. But there could be more.
At the end, the goal is to capture the meaning of something so that it's independent of the syntax or the language, right?
Yeah. So meaning exists independently on the language. That's a good point. So I mean, but there are different certain connections. So we use the language as means for communicating meaning. Det ska resonera om komplexitet. Vilka teknologi man kan använda för att hyra ut de där räkna. Precis. I gammal
First is English, but some of the English language is first concept English, then English.
Hur kan man översätta informationen till någonstans? Om ni skulle jag vill bara att ni borde tänka på just komplexiteten av problem på det finns mening som kommuniceras. Det finns sätt att kommunicera och sen det finns olika sätt att kommunicera sammanhang. Så skulle behövas att representera det här meningen och göra de där bänkarna. Precis. Så det är ett problem. Also to this discussion, I want to add. I want to confess here. As I said, I don't. This topic is very complex. When I start to think about it, my brain actually starts to explode because I mean it's a complex problem. It's a problem of really artificial intelligence. General, we can do that. I mean, somehow very efficiently. So we speak on many languages. We learn foreign language, so we kind of add the structure to our communication. We still, and we are able to describe information, and we have implicit agreement. Really implicit agreement. It's not that we have a database of rules that we use all the time, which helps us to analyze this variety of information and such. Also, again, I'm kind of very. I cannot make my own opinion about this recent news about AGI. That I mean, people are just very, very close to creating AGI from OpenAI systems. So I read this news like even yesterday on SVT. It was so. It means that somehow they really efficiently solve this problem. But that's what I want to kind of discuss. So it's not that you suggest me, but exact solution. But maybe the idea is that you appreciate the complexity, of this general formulation, and creating a technical system that does it. But again, so maybe so let's see what we have here in chat. Well, here in the class we haven't discussed anything yet. But listen, we take a break. So yeah, keep on thinking about it. And yeah, and in 5 minutes, so we will resume. But you did have this introductory course to AI, right? So you know about word embeddings, for example. Somewhat, at least you know this concept of word embeddings. Yeah. Yeah. Mm-hmm. Because I mean, technically, so that would be also one of the, at least in the deep learning community, that people say that they learn the meaning. So the word embedding is kind of one of the possibilities of learning meaning in a rather mechanical way. So you can create representations that somehow, with respect to a chosen measure of similarity, would reflect semantic similarity, right? So you for example, in this Word2Vec, so you have embeddings, so like vectors of real numbers. You can, for example, use dot product or cosine similarity. I mean, now we are talking technically, but I mean this measure would tell that, for example, Madrid and Paris. I mean, the embeddings of Madrid and Paris are kind of close to embedding of capital. I mean, this kind of things. Then also, I mean, if you follow this way, so at least in my mind, I continue thinking about these large language models, I mean, which are really capable, like, and it looks like this, I mean, current trend is really towards creating this super huge language models, which somehow links to meaning. So it's like embeddings plus plus or 2.0 or 3.0. But to me, again, I didn't see any kind of deep technical paper on really which really discusses this transition. So we have so this large language models. I mean, how they do that. So currently, I mean, at least in the current state, my understanding is that still it's more of statistical based link. So it's, but again, so I have more. My knowledge here is limited. Maybe you have read if you were curious about OpenAI and ChatGPT like solutions. Do you know any details on how they formalize semantics?
Whatever, I don't think there's much public information at all.
Exactly. I mean, that what I mean. So maybe we are drifting away from the content, but I think that's a kind of a discussion that needs to be taken very seriously. There is a lot of lots of mysticism in this discussion about AI taking over the world. But even in the statement that they claim that they will create artificial general intelligence in this short on short term, really. I don't know, maybe, but to me, it's really unclear how technically they do this link. Moreover, the mapping between languages now it's pretty much solved, I think. So so again, this automated translation, so that's pretty much accurate now, right? But to me, the troublesome is actually this link. So, what did you come up with? Can you maybe say loud your ideas? And in Zoom? Okay, I guess it's too early in the morning. Still, yeah.
We didn't come up with a solution, but more like
Challenges, but even challenges. What are the challenges here? So
it's sort of like if you would have sort of like fee structure, it would be like if I had a yellow bubble with a statement, like the blue bubble with the meaning would be very dependent on the person saying.
Mhm.
So you would have like a field structure that categorizes the person and the person is.
Mhm. Absolutely, but again, so and that links. So to me, that what you say, that I mean, so it's really, I mean, this link from yellow to blue bubble is difficult because really, I mean, so same, so different ways one can express certain facts and certain relationships. It is difficult. It's really, really difficult. And yet I don't know what they mean by this large language models and the development of LLMs. How exactly they solve it. Yeah, so, but there are ways. There are ways. So I mean, so that's what we observe since past, say, 2-3 years. So people are attempting to automate exactly this link. So as I told you, so the language as a communication means, I mean, it is feasible. So to me, it's much more straightforward how to automate. So that's more about translation. So how to map from one sentence to another sentence. That's pretty much solved, but still, it's kind of well, it's an extra computational computing, an extra computational step to do that. What we will be talking about, so all this discussion on, and maybe even my value request to you to discuss possibilities was really maybe to motivate an alternative and more engineering approach to the problem, which we will be looking at, and it is about explicit representation, explicit representation of meaning. So we create this representation in a unified way, and somehow we integrate it with this software agents, which in an automated way now can match the meaning, which is expressed in different in different ways. So if we do have this kind of formal representation of different contexts, then instead of using vague communication channel, like or ambiguous communication channel, not vaguous, ambiguous communication channel like language. So we can now, I mean, build a system, so a technical system that explicitly communicates knowledge. And in this case, I mean, we remove this kind of misunderstanding. So we now can match, for example, one meaning against the other and do the reasoning, like, I mean, or agreeing on a term, or agreeing on terms is one of the reasoning modes that we can perform. So like matching the content. Right, and that's what we will be talking about. So how to describe semantics. And if we can do that, then we can use it for many different practical purposes, like identification of situations or relationships slash properties, evaluation, decision making, etc. So what we will be talking about in the next few classes is about semantic technology. So really knowledge representation. So some existing frameworks for knowledge representation. So we will be and digital tools that are that assist us to work with knowledge. And the idea is that with these tools and methods for representing meanings, we can create large-scale software technology where information or meaning information is processed well, virtually at real time. And to do that, and now in next few slides, I want to give you a kind of more practical motivation to look at it. We will consider the case of the transition. So we will consider web, so World Wide Web, as the subject and or as the target system. Well, it can be. I mean, we could take any other system, but we take World Wide Web because of the scale again, and we will talk about how to make a transition from so-called syntactic web, so that we still have now, to a large extent, to more semantic web, to a web of knowledge. So a resource which would enable reasoning on this information. Well, it's very simplified view of the current state of the web. So obviously it's not only links, so it's much more to it nowadays. But still, the current web is about linking resources. So so not much more than that. The resources are now very diverse. So like including media and social stuff, but still we are interlinking these resources, and the task of retrieving information or kind of navigating through this information is still kind of outsourced to humans as intelligent beings. And in the second module, we will be talking about technologies which were developed and suggested many years ago, actually, under the initiative which is called Semantic-Web. So so it was very popular once upon a time, and many useful resources have been developed. And standards. So what is more very important, so these technologies were standardized, and the standards exist, the tools exist, and can be used. What doesn't exist is the actual target. The semantic web doesn't exist. Whether yet or will not exist at all, so that's a bit unclear. So I found a rather recent discussion about it. So I put a link in Canvas. You can read about it. About the need, still motivating the need for turning web to web of knowledge. basically from web of information to web of knowledge. And why I think it's still very useful to know about these techniques that we will be talking about is because independently whether this technology will or will not exist, so these are the thought through tools that you can use in other different contexts, and which is really good to be aware of. So we are about to talk how to turn, as I said, interlinked information into interlinked knowledge. Resource where or the interlinked knowledge technology in which we have a variety of resources, and these resources will be integrated, and they will be integrated by means of these semantic annotations. And the semantic annotations will also will be compliant to the definition of domains of knowledge. And this definition of domains is another word, is ontology. So it's a collection of definitions. And this collection of definitions needs to be agreed upon. So you need to share this definition across the actors that want to participate in this knowledge exchange and knowledge reasoning. So that's obvious. So again, on the level of definition, ontology is a collection of facts, relationships, properties about target domain on which you target domain of knowledge, which kind of represents a standard to describe different instances of resources via semantic annotations. And the resources are really diverse. So, and that is the state of the internet now. So, I mean, we are long. We have made a long journey from, I mean, the web to transition web from simple interlinked web pages and informational resources to integrating these different other resources like machines, world object, physical objects to some extent, etc., etc. So that. But if you think about it, so there is no kind of ultimate solution to kind of this global scale, the global scale information representation into knowledge. And again, so we will be talking about a framework for describing resources, which is called a resource description framework. So it's a standard so conceived by a World Wide Web community. And so here it is illustrated, I mean, what we want to achieve at the end. So we have some digital resources that we want to annotate with with some description of properties and relationships, which are kind of described in a agreed way in an ontology. So and in this way, so we can even we integrate. So in if you think about it, so we integrate even us users, humans, natively into this digital universe through this kind of description. Yeah. So again, on a very simple way, in a very simple case, so we can start by describing web resources. So that's I mean we again, so we transition from kind of only linking of information. So from one web page, so we have a link to say one web page about with information about country like Sweden. We have a link to Stockholm. Then it has it's a page in itself, which has this other hyperlinks. So we will introduce extra extra pieces of information which encode the relationship, so the semantic relationship between them. Existing projects, again, so that's long living projects, so they exist. We will look at them, so you can have a look separately. So let me see if I have this page is open somewhere. No, not that one. Yeah, I think this is the DBpedia. So you can well browse through this site. Another thing is Wikidata, and so that were two projects of Wikipedia, obviously, to turn information into knowledge, basically in this unified manner. So they are slightly different, is in a way that Wikidata focuses on creating metadata to supplement Wikipedia documents, while DBpedia is focusing on linking this data from the document. So and you will see it's slightly different. So basically, if you browse DBpedia, so it is kind of meta description of Wikipedia pages, which is suitable for automated processing, like semantics search. All in all, we are looking towards, or we are, I mean, this discussion, this module goes towards, you know, a bigger goal of creating knowledge graphs. So that's that is a complex business. And so it is a kind of global structure that incorporates all possible information that is suitable for kind of search. So that so this technology that we are talking about will be is one possible ways for implementing them. So we will see how this knowledge graphs could be represented with this RDF framework. Well, RDF and OL, so these are two languages for representing data, and we will also see query languages, so like Sparkle, which allows to retrieve certain allows knowledge retrieval from these sources. I want to make kind of that picture in your mind, so the difference between the database, and that's what we are talking about here. So in databases, so again, so that refers to the very first slide. So database is a closed thing, so it's it is limited to the information that exists in there. So data records, but data records, on each record we is identified by exact number of fields. Here we are talking about knowledge base. So basically, so there is no single source of structured data. So we will be somehow we will try to impose certain structure onto unstructured data, which would allow database-like search. So the components of semantic web. So at the very end, those are applications. So we are not concerned with that. So that's because I mean that's kind of semantic web specific. So these are applications which deal with knowledge. So for example, some trading agents that analyzes profiles of, I don't know, stocks or whatever to decide and to decide which stocks are more suitable to, I mean, for a given portfolio or something. But again, so that's one of the problem points with the semantic web in terms of killer applications. So that's so we are focusing really on the technology here for annotating knowledge in unstructured resources. So we will be talking about really how to annotate resources. We will be talking about a unified way of describing domain knowledge in terms of ontologies. We will all these, I mean, these two components will be used for reasoning. So that's at the end what we want to do. So it will be a special kind of reasoning. So I would say way simpler than we did in case of even propositional logic, but useful anyways. And to do that, so we will go through example of languages, so programming languages that support this. We will also, I will, or for lab 2, you will use a tool for constructing ontologies, which is Protégé. And again, so altogether, at least I mean, I hope that if you will be working with this knowledge representation at some point, at least you will be hearing about this. And in my opinion, it will be a symbiosis of some learning based kind of knowledge representation and more structured engineering based. So there will be a certain convergence, which is currently not so evident and visible. So what we will begin with, and that will be the topic of next class. So we will be talking about resource description framework, RDF, and a RDF schema, so a standard that defines vocabulary. The information about this module, well, obviously, I mean, a lot of practically useful information will be available in lecture notes. So they all are available already for the entire module in Canvas. Then RDF schema, Sparkle, Swirl, all these acronyms. So they're available. They have extremely good documentation and tutorials on the web. So it's standard, so with very documented examples. So and obviously for this second midterm, you are free to use these open resources, whatever you find suitable for this. Yes. So we do a slow start today. So introducing resources and how to represent resources in RDF. So again, so resource can be anything. So it can be it can be a single web page. It can be a part of the web page. It can be collection of pages, etc. But all in all, and obviously just any object that that is not accessible via the web. So RDF statement is very simple. So so you have you say that so resource, certain resource has a property which is a value, or a resource can have another resource as a property. So, for example, you can encode semantic relation into RDF statement. So, if we take, for example, my web page at SRT, just on the level of web pages. So now we are talking about digital resources accessible via the web. And so what we want to explicitly link. So we introduce that this my web page refers to. So so you create semantic hierarchy of this digital object, but underneath so we are talking about me as a non-clickable object, and I also in this case so my link to the employer is through the property employed by, for example. So that is the type of this relationship where you have a resource which is linked to another resource. An example of a situation where resource is linked to certain value, so is here. So we have again, so an example of a birthday. So me as a person has a birthday, and also it can be annotated on the in a digital resource. So, and we are about to describe all these relationships between the items, informational items that that exist between like real objects and to the digital world, and between the objects in the digital world. When do we do that? So the idea is that I mean, it's part of the development. So when we do the annotation, so when we create a digital resource, we also describe these different properties and embed them somehow into the digital representation. And for that we need identification. So that's not that's totally not new for you. So we have this uniform resource identifiers, which are used to annotate anything, basically. And we use this simple syntax. The syntax is really simple. So it's subject, predicate, object. so subject is a resource that we want to annotate. Predicate is a statement. So it describes the property of the resource, and the object is whether it's a value or another project. So it's creating RDF statements is more is very similar to like filling a form, a questionnaire form. So in this subject predicate object. So that's the kind of ideology you should have in mind. Etc. And here, for example, so this is the first instance where you see that we transition from linking to a specific resource. So, like for example, so employed by me employed by say LTU. So the idea here is that we will we want to transition to saying that me and so information of me is available through this link, for example, is employed, and we link to a description of the employer. So not to the resource of the employer, but it's a description, which is existing somewhere else. Well, in the standardized manner. We will see examples of it, concrete examples of it next time. And in this way, so we describe all possible relationships. So we turn a simple digital information resource into more knowledge representation, so which you can navigate and discover different things. So, but to do that, so we need to adopt this thinking. So we need to link each and every concept to the identifiers. So that's like this. So we need to very specifically say, so which John, for example, loves which Mary, and what loves mean in this very context. So what do I mean here? So we indicate, so we need to explicitly indicate, so where to take a definition of the of John. So by specifying its exact location of this definition. The same goes for Mary. So a specific individual is linked via or is referred to via the resource identifier. And finally, so we need to provide a reference to the definition, so to the semantic definition of love. And this semantic definition, it can exist in different ontologies. So now I use this word ontologies, like and different ontologies can have different definition of just love, but and that's okay, unless as long as we agree, so under which definition we are operating. And to do that, we indicate, so we use this ontology and this specific definition of love in this ontology. And in this case, so we remove the all the ambiguity of the initial statement. So so we turn just information into concrete description of meaning. And this is done. So we will use this URIs as part of our resource description framework. I think I shall stop here. So next time it will be more clear. So we will do some particular examples, and you can look at PDFs, so they are available, and maybe even try some of them yourself. Any questions? No? If any, so you know how to find it. Okay. See you next Monday. We have a chat. I have a question about my paper assignment. Well, you can wait. I will stop recording, and you can speak up. Stop.